Hey everybody, welcome to the first lesson in chemistry. In this first lesson, we're going to be looking at the properties of matter. So let's start with some basic vocabulary. When we say matter, we just mean the stuff that something is made from. So a book is made from paper. The paper is the matter that makes up a book. You or me, we are made from carbon and hydrogen and oxygen. This is the matter that we are made from. So everything that makes up an object or a living thing, this is the matter. For volume, the volume is the space taken by an object. Mass, well, the mass is the amount of matter that is inside an object. So if we add up all the protons and electrons and neutrons in every atom of every molecule that's inside an object, that is the matter. And we add the weight of each of those bits together, then we get the mass of the object. For the state, well, the state is the form which an object is currently in. So it could be a solid or a liquid or a gas. For physical change, this is when an object changes in the physical appearance, the physical properties only. A chemical change is a change which alters the chemical properties, that creates new compounds. Pause the recording now and write down this key vocabulary. So let's have a look together at lesson 1. The 3 states of matter. You probably already know about solids, liquids, and gases. Solids are hard things like ice cubes, pencils, and footballs. Water, paint, and vinegar are liquids that you can pour. You can also probably think of many gases, from the steam rising out of a pot of boiling water to the exhaust coming out of your car. So everything in the world around us is either a solid or a liquid or a gas. The computer that you're looking at right now, or the phone that is in your hand, this is a solid object. Something that can be poured, like coffee or Coca-Cola, is a liquid. And a gas is something that is in the air. So oxygen, carbon dioxide, these are gases in the air. The steam that rises up off of your coffee or tea in the morning is also another type of gas. Solids, liquids, and gases together, these are the 3 different states of matter. Sometimes matter will change from one state to another, as when a solid ice cube melts into a liquid puddle of water, which then evaporates into steam or mist as a gas. So there can be state changes. Ice is solid form of water. Liquid water that you're drinking, well, is a liquid. And the water vapor in the air, this is a gaseous form. But it's still water, it's still H2O. But it's changing the physical property, it's changing its state of being. In the solid state, matter has a definite shape and volume. In the liquid state, only the volume is constant. Constant means the same. The liquid takes on the shape of the container. So, for example, if you have a bottle of water and you pour it over the table, in the bottle of water, it will be in the shape of the bottle. So if we have a bottle of water, the liquid will be in the shape of the bottle. But if we pour it out, the liquids will spread all over the table. So the shape can change, but the volume will be the same. Now, in the gaseous state, neither the shape nor the volume is constant, as the gas spreads out to fill the size and the shape of its container. Now imagine that somebody is cooking delicious dog curry in the kitchen, and you are in the classroom. You can smell the dog curry, because the dog curry spreads out and reaches you where you are. Now, characteristics shared by all matter. Characteristics means properties, descriptions. We can usually see, touch, or smell matter, but not always. Normally we can, but not always. We cannot smell oxygen, for example. There are certain gases, for instance, that we cannot observe with any of our senses. Still, like all the other matters, these gases, they are made of particles, that are atoms. They take up space, they have a volume, and they have a mass. So all matter is made of small particles. All matter has space, and all matter has a mass. The mass is the amount of matter that is weighed in different locations. So there's an effect of gravity on matter. So on the moon, your weight will be less. You might say that right now on Earth you have a weight of 60 kilograms, but on the moon your weight would be about 20 kilograms. And that's because the weight is calculated by multiplying your mass by the effect of gravity. The effect of gravity on the moon is much lower. So although your weight can change, your mass will never change. Now, some notes that I would like you to copy down. 3 states of matter are solid, liquid, and gas. Water can be solid, ice, liquid, water. Water can be solid, ice, liquid water, or gas vapor. Matter can change state. All things are made from mass, and the weight is different depending on the gravity. Okay, so pause the recording and copy down this diagram. Now, we have solid, liquid, and gas. For the solid, liquid, and gas, we can see that the solid particles are very close together and they have a regular pattern. That means they are ordered. For the liquid particles, they are starting to spread out and they are random. For the gas particles, they spread out as much as possible. They fill the space where they are. Thinking about the movement, the solid particles only vibrate. That means they shake from side to side. The liquid particles can move past each other and the gas particles move freely. For the volume, the solid has a fixed volume. You know that, for example, a book will always have the same amount of space. An ice cube will have the same amount of space in the freezer. If you start to melt it and it starts to change into a liquid, okay, then the shape will change. But while it stays a solid, you cannot change the shape and you cannot change the volume. For liquids, they have a fixed volume. So if you have a cup of water and you pour it out on the table, it will still take the same amount of space. However, the shape will change. They have no fixed shape. For the gas, they have no fixed volume and no fixed shape. Gases spread out as much as possible and fill the whole area where they are. Now, physical properties of matter. Different types of matter can be identified by different characteristics or properties. So properties, characteristics, this just means how you describe something. Properties that you can observe with your senses are called physical properties. So the size, you can see, the shape, you can see, the color, you can see, the mass, you can feel it in your hand, the texture, you can feel it with your skin. The volume, you can hear, the taste and the smell. These are all physical properties, physical characteristics. To describe some of the physical properties of some sugar, you might say that it is white, that's the color. Sweet, that's the taste. A cube, that's the shape. Chemical properties of matter are a little bit different. Chemical properties describe how a substance will combine with other substances. So, for example, wood can burn. And when it burns, it combines with oxygen to form new substances, including the ash and the colorless, odorless gas. That's probably carbon dioxide. Wood's ability to combine with oxygen is an example of a chemical property. So, can something burn in oxygen? Can it combine with oxygen? Yes or no? Now, a physical change is quite easy to identify. Physical changes are things that you will see with your eyes or notice with one of your other senses. For example, if you have a piece of meat and you cut the piece of meat into smaller pieces, well, the meat is still meat, but you've changed the shape, and you can see the change of shape with your own eyes. Many physical properties can actually be, physical changes can actually be reversed. Chemical properties tend to be irreversible. So, for example, a physical change might be painting an egg color, but you could wash the egg and make it go back to how it was before. A chemical change would be frying the egg. You're physically changing the substance of the egg into something new, and you can't take a fried egg back to a raw egg. So physical properties often, but not always, can be reversed. Chemical properties are things that you cannot reverse. Now again, we have a few notes that I would like you to copy down. When a substance changes from one state to another, the change is also physical. So if you go from solid liquid to gas by boiling or melting or freezing or condensing, those state changes that are on the diagram that you copied down already, those physical changes are changes in state of matter. Water is still water, that is H2O, whether it is ice or liquid or air vapor, steam. Melting, evaporation, freezing, boiling, condensation, and sublimation. Sublimation means you change directly from a solid to a gas without becoming a liquid in the middle. All of these are physical changes. The temperature at which particular liquid will boil is called the boiling point. So we probably know that water, liquid water, will become a gas at 100 degrees Celsius. But not every liquid will boil at 100 degrees. 100 degrees is the boiling point for water. Alcohol burns at a different temperature. Gasoline boils at a different temperature. Also, the temperature that a liquid will freeze, that means turning from a liquid into a solid, is called a freezing point. Now, again, we know that is 0 degrees Celsius for water, but it is different for other substances. Do notice that this is degrees Celsius. Degrees Fahrenheit is the American one that you'll see in many examples in the textbooks. Degrees Fahrenheit and degrees Celsius are not the same thing. Finally, chemical changes. When the identity of the substance is altered, the change is called a chemical change. Chemical changes produce new kinds of matter. For example, rusting. If you go and you look at a piece of metal that's been outside for a long time, it's probably become brown. Now, the iron in the metal is combining with the oxygen in the air. This is called oxidation. So the metal and the oxygen combining together creates a new substance. So in this example, if you have iron and oxygen, we make iron oxide. Iron oxide is basically rust. So if you have an old table and you can see where it's going brown and you put your finger into it, it's probably quite weak. The new substance has new physical properties. Iron, the metal, is very strong, but the new substance, iron oxide, is weak. There is a chemical change. New things have been created. Now, again, copy down these notes. Now, each lesson, I would like to introduce you to a new type of skill. Today's skill is going to be understanding the adequacy of information. Adequacy means, is it enough? So when you look at a source, maybe writing or a picture, you ask, is the information enough to support the conclusions that are being drawn? For example, if you have a graph that looks something like this, which shows the oil consumption in America and the USA in the year 2008, well, that is enough information to show you how much oil is used in 2008. But if one of the conclusions that the question draws is that the usage is increasing or the usage is decreasing, Well, this is not enough information. Here we only know about 2008. There's no information there about other years. So this is not enough information to support the conclusion that is drawn. Their information is not adequate. So is the information adequate or not adequate to support a conclusion? Let's have a look at a question together. Pause the video and try to answer this question. Have you done that? If you've done it, then let's have a look together. Which of the following statements is supported by the information in table 4.1? Number 1, as the gold price rises, it will probably be replaced by silver in telephone handsets. Now we see gold. Gold is used for electrical contacts. Silver is used for plating. So, do we have enough information to choose answer 1? Well, not really, because gold is used for the contacts, silver is used for the plating. They're used for different jobs. So even if the price of the gold increases, because they're doing different jobs, there is no evidence that we can replace gold with silver. So number 1 is not supported by the information. Number 2, more zinc than chlorine is required to make a telephone handset. So zinc is used here for the brass die casting in the transmitter and the ringer, and chlorine is used in the wire insulation. But we don't know how much. We don't know how many grams or milligrams. We don't know what percentage. So we don't have any numbers. We cannot say it is more or less. 3, the chromium in telephone handsets could be replaced by cadmium if all the plastic housings were made red. Well, chromium, let's delete this. Chromium is the color in green plastic housing. And this says chromium could be replaced by cadmium. Cadmium is the color in yellow plastic. But here it's talking about making them red. But we have green and yellow with chromium and cadmium. So number 3 also is not supported by the information. Number 4, boron, which is used in the touch-tone dial mechanism, indium, which is used in the touch-tone dial mechanism, and silicon, which is used in touch-tone dial mechanism, is not found in all telephone handsets. Well, they are only found in the touch-tone handsets, not in other types of handset. So number 4 is supported. And then number 5, aluminium is more necessary than arsenic. Well, we see that aluminium is useful here. We see that arsenic is useful here, but we don't know which one is more important. So again, there is no support for answer number 5. So hopefully you have the main idea of today's lesson. Today we've looked at the 3 states of matter: solid, liquid, and gas. We've seen that everything is made of matter, and matter can go under physical change or chemical change. Physical change is just a change to its physical properties. Chemical changes is about creating something new. When we are answering questions, we need to look at the information and see, is the information adequate? Is the information enough to support the answers that are given? If you feel confident about today's lesson, go and try the quiz. Good luck, everybody.